Hello, so today we are going to do problems from biweekly contest 126. This is the third problem of this week's biweekly. Replace question marks in strings to minimize its value. So basically what we have here is we have S string and we have SI, which can be either one of two things, either a lowercase English letter or a question mark. And for a string T, we have another string T that has length M that also contains only lowercase English letters. Okay, and we define the cost of, by the way, just to clarify, this T is not in the input. The input is just S, which has a, you can see, for example, question mark or some letters and question mark. T is actually the letter that we want to return. So this one. And so basically with T, we should eliminate these question marks, and basically for that T that we need to construct, the cost of an index basically is the number of characters equal to that letter that appeared before it. What do we mean by that? Let's take a look at this AAB. So the cost for position 0 is 0 because there is nothing before. The cost for position 1 is 1 because this letter A, there is one A letter before it. So it's the number of the same letters that before it. So the number of frequencies of the same letter before it. And for position 2, the cost is 0 because there is no B to the left of it. Okay. And so the overall cost is just the sum, which in this case is 1. Okay. And our goal of this problem is to take S, replace the question marks in a way that the cost is minimized. And we want to return the T that we end up constructing with the minimal cost. Now, it may end up that we may have the same costs for different solutions. In that case, we want to return the lexicographically smallest one. And lexicographically means basically just basically, if you have AB and maybe AB is smaller. If you have AB and AC, AB is smaller. Okay, so that's the idea. Now, if we take a look at this first example, well, the smallest cost is to just do different letters. And since we want the lexicographically smallest one, we can just do ABC. Now, of course, it would AA, maybe C or even AAA would be smaller lexicographically, but the problem there is that the cost is higher. So this is the lexicographically smaller is only a tiebreaker if the cost is the same. Okay. Now let's take a look at this one. Well, the most optimal here is to put B here and C here. We don't want to put A because if we put A, then we increase the cost. And if we put B here and B here, we increase the cost as well. And so the smallest lexicographically and the smallest cost is this one. Now, if you take a look at the length of S is 10 to the power of 5, and S, the characters are lowercase English letters or question mark. So this tells you an open squared solution is probably not going to pass. So let's see how we can tackle it. Okay, so let's see how we can tackle it. Well, first, let's do a couple of observations. I think this problem, it helps to just not jump into the solution immediately, the first solution that comes to mind. It helps to go to first try a couple of examples and see. So for example, now if we just have a simple one where you have the letters and then you have the questions mark, then that's easy to do. Now, but you have to be careful because question marks can be anywhere here. But first, if we just have this case, then we can just take the next smaller lowercase letter that is not in there, right? So we can take just CD, for example, here. Just put CD here. And because the cost will be 0 for each because there is nothing before it, right? Because it doesn't make sense to take A because then you would have a cost of 1, okay? It makes sense for the optimal cost to just take a character that is not in there. And then for the part where the lexicographically smaller, it makes sense to take the next smallest lowercase letter that is not one of these two. Okay, so that's the first idea that we can come up with. But there are problems here because if you take a look, if we have another example, so I said the question mark can be anywhere. So if you have A, B, C, and then C, D, like in this case, What's the problem here? Well, if we just apply what we said here, the smallest the smallest lexicographically that is not present yet, so not present to the left side, then you would just do CD. But then the problem putting C here, right, will increase the cost of a subsequent one. So of one after the question mark. If you do D here, same thing, that will increase the cost for this one, because now the cost for this one would be 1 instead of 0. So what makes sense is to consider both before and after the question mark, and to use the next smallest that is not at all anywhere here. So E and F in this case. That would make the cost 0 for every character here. Okay? So that's the other consideration that we have, is that we want to consider also the cost of the subsequent ones, of the subsequent letter. So we need to care about the before and after. So we need to consider the frequency for each letter everywhere in the string before deciding what to do for a specific question mark. Okay, so that's the first thing. There is another complication, which is, let's take this big test case where we have question mark here. Now, what is the mean cost we can do? You may think, okay, let's just put the first smallest that is not anywhere here. Okay, so in that case, you put Z because it's not anywhere here, and then you put A here. But the problem is that this is not optimal, because once you put Z here, you could do another different one, which you put A first and then put Z, even though A already existed here. Okay? And you would have to put one of this one, you would have to put one of the one that exists, because we have all the alphabet except Z. And if we put Z twice, that still increases the cost by 1. If we put any other letter, it will increase the cost by 1. But this one is more optimal because it's smaller. So even for the question, so what does this tell us? Even for the question marks, we have to put them in a sorted order. Okay? So instead of putting ZA, we have to put A. So that's the other thing. So once we add a letter for question mark, we need to take it in consideration for the frequency for future ones, but we also need to sort it with future ones. Okay, that's the idea. Okay, so with those observations, we can do a solution. Now, the first thing we need to apply is this part here, where we need to take care of all the overall frequencies. So how do we do that? Well, we need to keep track of the frequency and put in the question marks only the ones with the smaller frequency, because if we have, let's say, AA question mark, B question mark, then it may, and maybe we have all the other letters, all until YZ. Okay, it makes sense here to take B and put it here. So what we can do is we need when we have something where we need to take the smallest frequency first, or the smallest value first, you should always think about using a heap queue, or basically min heap here, priority queue. And so, but the other thing that is important, that we saw that is important from this one, is we need to also pick the smallest. So our min heap need to have two things. It needs to have the frequency, and that's the highest priority because that determines the cost. But the next thing, if the cost is the same, we need to tie the tiebreaker needs to be the character itself. Okay, so how do we do this? Well, we need a heap, so we can just create a heap. Okay, and we need to calculate the frequency for all the strings in S. And then we need to create a heap of the frequency and the character. And this we do it for all the letters, because those that have frequency 0, we want to include them so that we can pop one of them and use it for a question mark, because so that those with frequency 0 are are popped first from the min heap. Okay, so that's the first. So that's the first consideration. What else should we do? Well, the other thing we should think about tackling is we need to I'm trying to think about how to phrase this in a way that is easy to understand. If you take a look at what I said here, which is if you take a look at what we mentioned in this use case here, it does make a difference what you add to the order you add in the question marks. So first we need to pick the smallest frequency overall, but we also need to sort them so that we put AZ in instead of ZA. So what this tells you is we need an array, let's call it replacement, that we can just put the values that are eligible to be replacing here. And this would determine it by the min frequency. And so once we have that, we can sort it so that, let's say when we have replacements are Z and A, when we sort, it would be A and Z. And the order we will add them back is A, then Z, so that we can have the smallest frequency. Okay? And so that's exactly what this does. So we have this list of replacements, and we go through the string, and if we find a question mark, we pick the smallest frequency, including 0, that we can get from the possible letters. And so when we do that, we add it to our list of replacements. But the other thing we need to do, remember what I said here, is that if you add a C here, that will increase the cost of this one. So we need to take into account the cost, the frequency increase when we add something here for a question mark. Now, another example you may think about this is, okay, if we add C here, we shouldn't add another C here. So how do we account for that? Well, one way to account for that is just to add it to the heap queue so that we increment it by 1 because we just used it. And so it should be considered for the next one as a frequency to take into account. And so we add it to our heap. Okay? So that next time, if this is not the smallest, we don't use it. But if it's the smallest, let's say we have a lot of question marks and we added a lot of letters, and now each of them has a frequency of 2. Each of them has a frequency of 2. Then it makes sense to add B again because it's the smallest lexicographical that will get us, it will increase the cost, but any other letter will increase the cost, and so it makes sense to take the smallest one. Okay, so that's the other thing here. Okay, so now, as I said, we sort. This is to take care of this case, ZA to AZ, and get the lexicographically smaller. Now, once we have this array that will have all the replacements for question mark, but we need to construct a string. If you take a look here, we need to construct a string that contains both the existing letters but the question mark letters. So how do we do that? Well, we just combine them. We just go through the string S, and if it's not a question mark, we just add it to the result. But if it is a question mark, we need to pick from our sorted list of replacement characters. So we just pick the smallest one because it's sorted, and then we increase the index so that we can go to the next one. And we do this until we combined everything together, and then we return the result. Okay? And that's pretty much it. The two crucial ideas here are to go through some cases and to see exactly what doesn't work and to take it into account in the implementation. Okay, and the two things that we did here are this heap queue usage so that we can pull the minimum frequency, but to do it for everything, for every letter. And then the other thing is to sort here so that we can get the smallest occurrence. But the third thing is to do the question marks separately so that we can also take them into account for the frequency here. And then this part is just evident because we need to add them back together, which makes sense. I hope this solution is clear. So we can, but for now, let's just implement it. Let's just put it in the in Leetcode solution, test it out. Okay, so we have, well, I didn't, I think. Okay. Okay, so now we can remove this, and then remove this as well. We don't need it, and we can run this. So we get the occurrences, we put them in the heap to consider the min for every letter, not just for those in S, because we want those that have frequency of 0. And then we collect all the replacements for question mark in this list, we sort them, and then we combine them with the existing letters. And now if we submit this, it passes. And yeah, that's pretty much it for this problem. I hope this was helpful. Thanks for watching, and see you on the next one. Bye.